After watching the Esri video, you're probably feeling pretty excited about all the amazing ways that GIS is used and applied. But as a person who wants to do the using and applying, such as an introductory GISer, you need to understand how it works. In this brief overview for week 1, I will provide a little more context as to what GIS is and the essential function of data and layers as a means for understanding how it all comes together and why. I have two ways of seeing it. In the first, the term is split into two. I like to differentiate between geographic information and information system. Geographic information is a particular kind of information we also like to call geospatial data. This is any kind of information that can be attached to a real-world location using coordinates. For example, where you are sitting right now has a coordinate. Attached to that coordinate is all the information, otherwise known as attributes, about what's at that coordinate. Demographic data about you, information about the building that you're in, what it is used for, when it was built, property tax rate, etc. And this all becomes data that is mappable. The information system, however, is another broad term for an integrated system for collecting, storing, and processing data, and technically can be anything from a computer to an entire institution. In this case, we are referring to the software used to collect, store, and process the geospatial data. This is our hardware, the computers we use, the software, and in this case, we're using Esri's ArcGIS Pro and their ArcGIS Online platform. We also can't forget about the cloud and the internet data processing centers we rely on to access and manage an increasing amount of our data. The next way I like to conceive of this relationship is with these four elements here. The person, which is the thinker or the analyst, the question, problem, or motivation for exploring something, the data needed and collected to answer that question, and the hardware and software to store, process, and analyze it all. This all equals GIS, and perhaps the most important way to conceive of how GIS makes data analyzable is through the creation of layers. All that data, when put into GIS, is made usable by defining the data model. This graphic here shows some examples of layer types. Some are points, lines, and polygons, while others are rasters. Let's look at the two different data models in the following slide. As we can see here, data models are either vector or raster. In this class, we will work almost exclusively with vector data. Vector data is any information that is not a raster. While we will explore rasters in greater detail at the end of this class, suffice it to say that it is geospatial data resulting from satellite imagery production. Therefore, if the data is not raster data, then it must be assigned to a certain shape in order to be used in GIS. We call these shapes a geometry, and these are divided into points, lines, and polygons. So, to step back for a moment, broadly speaking, a geospatial analyst is in charge of taking data in a spreadsheet format and processing it according to the needs of the project and the kind of phenomenon it is supposed to represent. For example, a building location could be a point or a polygon. A river could be a line or a polygon. It really just depends on other factors and the needs of the project. And while you will not be doing that in this class, it is important to understand that this has happened as preparation for your lab work. All the data you see has been neatly packaged and defined for you by the authors of the book. But in the real world, it can be messy and difficult to tame. Whew, what a relief. To close, a few notes about Chapter 1. Obviously, it's the first chapter, and as such, it's actually pretty easy. Take your time orienting yourself to the basics, finding the data, navigating the software, and understanding terminology while cruising around a basic geospatial exercise. Read the introduction, and I will say this all the time because the chapter's intros are short and really help give some shape to what you're going to do in the lab. Also, read the lab instructions carefully. It starts pretty simple, but the labs will quickly become much more detailed. Practice focusing on the directions. I wish I could say it was going to be easy, but if you take your time, it will at least feel smooth. Last but not least, take a moment to appreciate the scope and complexity of what is possible within GIS and have a little fun doing it. Okay, thanks. Bye for now.